MSHA, the Mine Safety and Health Administration, mandates ground rod installation for portable rock crushers primarily for safety. These ground rods fulfill two essential functions: firstly, electrical safety, and secondly, lightning protection. Regarding electrical safety, the ground rods offer a low-resistance pathway for electrical current to safely dissipate into the ground. This is particularly important during ground fault events, which occur when electrical current unintentionally escapes from the equipment's enclosure. By directing the errant current to the earth, the ground rods mitigate the risk of uncontrolled current flow through the equipment itself or, more critically, through personnel, thereby drastically reducing the potential for electrical shock hazards and minimizing the possibility of damage to the machinery. Moving on to lightning protection, ground rods effectively act as lightning attractors and redirectors. In the event of a lightning strike, the ground rod provides a preferential path, channeling the immense current safely into the earth. This process allows the energy of the lightning to dissipate harmlessly, preventing it from damaging the rock crusher's sensitive electrical components and, most importantly, safeguarding personnel from the devastating effects of a direct or indirect lightning strike. In the specific scenario of a portable rock crusher setup, MSHA often stipulates the use of two ground rods, each serving a distinct purpose. The first ground rod is to be bonded directly to the metal frame of the rock crusher. This connection ensures that the entire metal structure of the machine is effectively grounded. Should any metal component of the crusher become energized due to an electrical fault, the ground rod provides an immediate and low-resistance path for the fault current to flow to ground, promptly triggering overcurrent protection devices such as circuit breakers or fuses. This action quickly de-energizes the circuit, preventing sustained electrical hazards and potential equipment damage. The second ground rod is to be bonded to the control box, which houses the crusher's electrical components. This grounding measure is aimed at protecting the sensitive internal components of the control box from electrical faults and transient voltage surges. By grounding the control box, a stable reference point is established, minimizing the risk of damage to critical control circuitry and ensuring the reliable operation of the rock crusher. To summarize, the MSHA requirement for ground rods on portable rock crushers is a crucial safety measure designed to protect both workers and equipment. The ground rods provide a safe and effective means of dissipating electrical faults and lightning strikes, thereby reducing the risks of electrical shock, equipment damage, and lightning-related incidents. Understanding and adhering to these grounding requirements is of paramount importance for ensuring a safe working environment in mining and quarrying operations. The low-resistance path created by the ground rods is critical for proper electrical safety. When a ground fault occurs, the current will follow the path of least resistance, which should be the ground rod. This causes a large amount of current to flow, tripping the circuit breaker or fuse and shutting off the power to the equipment. Without a proper grounding system, the fault current could flow through a worker, causing serious injury or death. The ground rods also help to protect against voltage surges caused by lightning or other electrical events. These surges can damage or destroy electrical equipment, but the ground rods provide a path for the surge to dissipate into the ground. The specific grounding requirements for portable rock crushers may vary depending on the size and type of equipment, as well as the specific site conditions. However, the general principles of grounding remain the same. It is important to consult with a qualified electrician to ensure that the grounding system is properly installed and maintained. Some additional points to consider regarding grounding systems for portable rock crushers include the type of ground rods used. Ground rods are typically made of copper or copper-clad steel and must be of a certain length and diameter to provide adequate grounding. The depth that ground rods need to be driven to will vary. The soil composition and resistance will affect the ground, as well as how deep the rod needs to be. The resistance of the grounding system should be measured regularly to ensure that it is within acceptable limits. This can be done using a ground resistance tester. The grounding system should be inspected regularly for damage or corrosion. Any damaged or corroded components should be replaced immediately. All electrical connections in the grounding system should be tight and secure. These connections can create resistance and reduce the effectiveness of the grounding system. Workers should be trained on the proper use and maintenance of the grounding system. They should also be aware of the potential hazards of working with electrical equipment that is not properly grounded. Grounding is an essential safety measure for portable rock crushers. By following the proper grounding procedures, you can help to protect workers from electrical shock and equipment from damage. The installation and maintenance of ground rods is not a one-time event. Regular inspections and testing are crucial to ensure their effectiveness over time. Soil conditions can change, corrosion can occur, and connections can loosen, all of which can compromise the integrity of the grounding system. Therefore, a proactive approach to grounding system maintenance is essential for maintaining a safe working environment. In addition to the physical installation and maintenance of ground rods, it is also important to have a clear understanding of the relevant safety regulations and standards. MSHA has specific requirements for grounding electrical equipment in mining and quarrying operations, and it is important to be familiar with these regulations. Compliance with these regulations is not only a legal requirement, but it is also a critical step in protecting workers from electrical hazards. To further elaborate on the purpose of grounding, it is important to understand the concept of a ground fault. A ground fault occurs when an energized conductor comes into contact with a grounded surface, such as the metal frame of a piece of equipment. This can happen due to damaged insulation, loose connections, or other electrical faults. When a ground fault occurs, a large amount of current will flow through the grounding system. This current will trip the circuit breaker or fuse, shutting off the power to the equipment. Without a proper grounding system, the fault current could flow through a worker, causing serious injury or death. Therefore, the grounding system provides a critical safety barrier, protecting workers from the hazards of ground faults. Furthermore, grounding also plays a role in preventing electrostatic discharge, also known as ESD. Electrostatic discharge is the sudden flow of electricity between two electrically charged objects caused by contact, an electrical short, or dielectric breakdown. ESD can damage sensitive electronic components and can also ignite flammable materials. By grounding equipment, static electricity can be safely dissipated, reducing the risk of ESD-related damage or ignition. In addition to the two ground rods that are typically required for portable rock crushers, there may be other grounding requirements depending on the specific equipment and site conditions. For example, it may be necessary to ground other metal structures in the vicinity of the rock crusher, such as conveyors, hoppers, and walkways. The purpose of these additional grounding measures is to create a comprehensive grounding system that protects workers and equipment from electrical hazards. To ensure that the grounding system is properly installed and maintained, it is important to use qualified electricians who have experience with grounding electrical equipment in mining and quarrying operations. These electricians will be familiar with the relevant safety regulations and standards and will have the knowledge and skills necessary to install and maintain a safe and effective grounding system. In conclusion, MSHA's requirement for ground rods on portable rock crushers is a crucial safety measure that is designed to protect workers and equipment from electrical hazards. The ground rods provide a safe and effective means of dissipating electrical faults, lightning strikes, and electrostatic discharge, thereby reducing the risks of electrical shock, equipment damage, and ignition of flammable materials. By understanding and adhering to these grounding requirements, you can help to create a safe working environment in mining and quarrying operations. Finally, it is worth emphasizing that grounding is not a substitute for other safety measures. It is important to use proper lockout-tagout procedures when working on electrical equipment, to wear appropriate personal protective equipment, and to follow all other relevant safety regulations and standards. Grounding is just one component of a comprehensive safety program that is designed to protect workers from all types of hazards. The effectiveness of the grounding system relies on several factors, including the soil resistivity, the depth and spacing of the ground rods, and the quality of the connections. Low soil resistivity allows for easier dissipation of fault currents, while deeper and properly spaced ground rods increase the surface area in contact with the soil, further enhancing the grounding capability. High-quality connections ensure that the current can flow freely from the equipment to the ground rods without encountering any resistance. Regular inspection should include checking for loose connections, corrosion, and any signs of physical damage to the ground rods or connecting wires. It is also important to verify the integrity of the bonding between the ground rods and the equipment frame and control box. This can be done using a low resistance ohmmeter to measure the resistance between the ground rod and the equipment. A high resistance reading indicates a poor connection that needs to be addressed. In addition to visual inspections and resistance measurements, it is also recommended to perform a ground resistance test periodically. This test measures the overall resistance of the grounding system and provides an indication of its effectiveness in dissipating fault currents. The ground resistance should be below a certain threshold, typically 25 ohms or less, to ensure adequate protection. If the ground resistance is too high, it may be necessary to install additional ground rods or improve the existing connections. It is also important to consider the impact of environmental factors on the grounding system. For example, dry soil can significantly increase the resistance of the grounding system, reducing its effectiveness. In areas with dry soil, it may be necessary to water the ground around the ground rods periodically to maintain a low resistance. Similarly, freezing temperatures can also affect the grounding system by increasing the soil resistance. In areas with freezing temperatures, it may be necessary to install the ground rods below the frost line to ensure that they remain effective during the winter months. The selection of appropriate ground rods is also crucial for ensuring the longevity and effectiveness of the grounding system. Copper-clad steel ground rods are a common choice due to their good conductivity and resistance to corrosion. However, in highly corrosive environments, it may be necessary to use stainless steel ground rods or other specialized materials. The size and length of the ground rods should also be selected based on the specific site conditions and the requirements of the electrical system. Larger and longer ground rods provide a greater surface area for dissipating fault currents and can improve the overall effectiveness of the grounding system. Proper documentation of the grounding system is also essential for ensuring its long-term integrity. This documentation should include the location of the ground rods, the type of ground rods used, the resistance measurements, and any maintenance or repairs that have been performed. This information can be used to track the performance of the grounding system over time and to identify any potential problems before they become serious. In addition to the technical aspects of grounding, it is also important to emphasize the importance of safety training for workers. Workers should be trained on the proper use of electrical equipment, the hazards of electrical shock, and the importance of grounding. They should also be trained on how to inspect the grounding system and how to report any problems or concerns. By providing workers with the knowledge and skills they need to work safely around electrical equipment, you can significantly reduce the risk of electrical accidents. Finally, it is important to remember that grounding is an ongoing process that requires continuous attention and maintenance. By following the proper grounding procedures, conducting regular inspections and tests, and providing workers with adequate training, you can ensure that the grounding system remains effective and that workers are protected from electrical hazards. This proactive approach to grounding is essential for maintaining a safe and productive working environment in mining and quarrying operations. The goal is to minimize the risk of electrical hazards and ensure the safety of everyone on site.